In the rapidly evolving landscape of space exploration, the trend towards rocket reusability is gaining momentum. Nearly every next-generation launch vehicle incorporates some form of reuse strategy to enhance cost-effectiveness and launch frequency. However, ULA's Vulcan, which recently completed its inaugural launch, stands out as a fully expendable rocket in a sea of reusable counterparts. While its maiden flight was a success, all the hardware used, despite its quality, was discarded after just one use, raising questions about sustainability. Despite this, United Launch Alliance has ambitious plans to modify the vehicle for future missions, including the potential reuse of the BE-4 engines. In this video, we delve deeper into ULA's strategies for incorporating reusability into Vulcan's future missions and explore the benefits and challenges associated with this approach, and more in today's episode of SpaceX Flight. For quite some time, ULA CEO Tory Bruno has been vocal about his views on rocket reusability and its viability. Notably, he's emphasized the importance of reusing the engine section of Vulcan boosters. In a recent address at a space conference, Bruno underscored the value of preserving the BE-4 engines with each launch and explored potential enhancements for the Vulcan rocket. Delving into the heart of hardware recovery from space unveils a complex journey marked by atmospheric re-entry, deceleration, and precision landing. When it comes to re-entry, there are two primary methods: retropropulsion or leveraging atmospheric drag. ULA has chosen the latter approach, relying on the Earth's atmosphere to slow down the hardware. This entails equipping the hardware with an aerodynamic shell, fortified with a resilient thermal protection system. This crucial setup shields the payload from the high heat encountered during re-entry. Once through Earth's atmosphere, the two BE-4 engines would continue their descent, aided by parachute deployment. This strategic maneuver ensures a gradual slowdown of the hardware. Upon reaching a certain velocity, the engines would transition to a planned soft water landing, gently touching down on an inflatable shell. Following this, ULA would undertake the crucial task of recovering the hardware, bringing it back to land for meticulous refurbishment and preparation for future missions. As per Bruno's insights, it could take a couple of years to fine-tune the systems for engine reuse. Regarding the economic aspect of the plan, he also mentioned that the design will break even in just a few flights. This feasibility is bolstered by the heightened demand for the vehicle, largely propelled by Amazon's Project Kuiper, along with Sierra Space's Dream Chaser spaceplane. Now let's ask, why are they only reusing the engines? ULA struck a deal with Blue Origin to procure the company's BE-4 engines for the Vulcan rocket. Currently, with Vulcan being expendable, each mission entails purchasing 2 additional engines, each costing around $20 million. This not only adds to the engines Blue Origin must produce, but also underscores the importance of considering engine reuse. Interestingly, the BE-4 engines were designed with reusability in mind, particularly for Blue Origin's New Glenn reusable vehicle. This forward-thinking approach means the engines are operated at a moderate level to minimize wear and tear, aligning with Blue Origin's vision for a sustainable rocket architecture. Blue Origin faces a significant uptick in demand for its engines, not only from ULA, but also for their own New Glenn vehicle. Tory Bruno envisions Vulcan flying multiple times per month, with approximately 38 launches slated for the vehicle in the near future. This translates to a demand for around 76 engines if Vulcan remains fully expendable. Cost is a pivotal factor in this equation, as the engines each represent 2/3 of the value of the entire first stage. By focusing on refurbishing these engines, ULA aims to achieve a substantial reduction in costs while simultaneously enhancing launch frequency. In an effort to trim down the staggering $100 to $200 million price tag associated with launching the rocket, ULA has been actively striving to remain competitive in the fiercely contested launch services market. Cost considerations notably played a pivotal role in ULA's decision to retire its other vehicles, namely the Delta IV Heavy and the Atlas V. This latest cost-saving initiative could potentially set the stage for achieving full reusability of the Vulcan, ensuring its position as a formidable and competitive launch vehicle both now and in the foreseeable future. That's all for today's episode. We really hope you enjoyed it and learned something new. Please share your thoughts with us in the comment box below. We value your input, and it helps us create better videos for you. Thank you so much for watching, and we'll see you next time.